All right, I'm Peter Brimehurst.
I'm John Brimehurst.
I'm Håkan Larsson.
I'm Eric Lundstrom.
All right, this is our presentation. We titled it Farming for the Future. I'm going to start off with a quick question here. Which of the following is considered to be the most destructive invention throughout human history by many historians? Do we have any guesses? I agree with that one, but it's actually not true. So it's actually the plow. The plow has caused the most destruction through erosion.
Okay, so right now the world population is at 7 billion, and 1 billion of those people face hunger every day. And in 2050, the world population is predicted to be 9 billion, and according to the UN, we must double the food production in order to prevent global starvation. So it brings to the conclusion that we either need more farmland or more efficient farms. And the Scientific American predicts that we have 60 years left of productive farming if the current tillage practices continue, and that is because it takes 100 years to produce 3 centimeters of topsoil. And current tilling practices are causing environmental concerns, including erosion, CO2 emission, deforestation, and water contamination.
All right, so the problem is that conventional tillage methods present large negative environmental impacts with wind and water erosion. It reduces longevity and fertility of the fields with nutrient loss hooked to that erosion, and it will lead to yield reductions in the future if we continue to practice such methods. And then here we have a quote from William Bryant Logan. He's an author who writes about the environment. And he says, "A soil is not a pile of dirt. It is a transformer, a body that organizes raw materials into tissues. These are the tissues that become the mother to all organic life." So then our question is, how can farmers maximize their production of their fields, lessen their impact on the environment, and increase the longevity and fertility of their fields for the future? So our potential solution is reduced tillage, and as you can see in the picture, it takes 5 tractor passes for conventional tillage, and that's just because you have to till, and then you have to cultivate and plant, and then cultivate again. Whereas with reduced and no-till, there's much less tractor passes that need to be done to accomplish the practices. So.
All right, so this is a table showing the methods being used in Dakota County. And this is from 2007 since the survey ran out of money and they couldn't do any more current surveys. So conservation tillage is more than 30% residue is present on the field. Reduced till is 15 to 30% residue. Intensive till is less than 15%. And for corn, it shows that there is only 30.8% of conservation tillage. And with the reduced and intensive till, that is what mainly is being used right now. In today's presentation, we will be comparing reduced tillage and conventional tillage soils. Based on the 5 qualities of good soil, we will compare the economic benefits, the environmental effects of each method, and a farmer's thought on different tillage methods. The 5 qualities of good soil are soil porosity, organic matter, temperature parameters, aggregate stability, and bulk density.
All right, the first quality of good soil we studied was soil porosity. It's the shape and arrangement of the soil particles, and you can determine it by the amount of solids compared to the amount of airspace in a certain volume of soil. And then you can see there's different packings. The cubic packing right there would have the most porosity, and the other one on the far left would be least porosity. And this is important because the pores hold water and nutrients and air in the soil, which helps plants grow. And there's 2 different types of pores, micro and macro pores. Micropores hold the water and macropores hold airspace. Both are very important. So ideal porosity will be about 50% solids, 50% pore space, with half pores being micro and half being macro. And then there should be some organic matter in there as well, which we'll talk about later. And here's some data. You can see from the pasture, which would be no till whatsoever, you have a variety of different pore sizes. Each color on that line there represent a different size pore. And then if you go down to plow pan and recompacted plow pan, you see that the variety of pores dramatically decreases. You also can see the total porosity in the pasture is 46%, which is getting close to 50. And you go down to plow pan, it's only 40%, and recompacted plow pans, 41%. And we did our own investigation. We used a percolation test. We inserted a coffee can into the soil, which had no bottom, and we poured a specific amount of water in there. And we did this on both a conventional tillage field and a reduced tillage field in similar areas and similar soil types. And this would measure how many micropores are in the soil. And here are the results. We compared no-till in a prairie to conventional tillage, and it took about a quarter of the time for the no-till to absorb the water as it took for the conventional tillage.
Which one of these soil samples do you think is reduced tillage, and which one do you think is conventional method? Any guesses?
Conventional's on the right.
Yep, conventional is on the right. All right, organic matter. Organic matter is the part of the soil consisting of plant and animal residues at various stages of decomposition. It provides a reservoir for groundwater. Organic matter is created with the help of many macroinvertebrates like worms, which takes the residue from the surface and brings it deeper into the soil. Organic matter allows for better water retention and more porous soil because of the plant and animal matter, and it allows for more water to be absorbed faster due to less compaction, which in turn lowers the runoff and erosion. As you can see in this table, there is an inverse relationship between the organic matter and the degree of tillage. The organic matter is way higher in the no-till than the plow. It's almost double. And meaning the less soil that is disturbed, the more organic matter that the soil will contain, and the reduced tillage or no-till will increase your organic matter in the long run. Temperature parameters. It is the window in which you can plant your crops. In Minnesota, it is generally from April 21st to May 6th for the best yields. And it is the ability of the soils to resist temperature change, meaning being able to resist frost and overheating. Why is it important? Soil that changes temperature quickly can frost over easier, causing damage to seedlings and in the seeds. And the crops can get too hot in the summer, and all these can reduce yields and in turn less money for the farmers. We did our own investigation. We created a temperature probe and we measured at 3, 6, and 9 inches. We wanted to see how soon the fields warmed up and how they remained stable through temperature change. So the blue line is the no-till and the red line is the tilled, and we found that the no-till started out much warmer, and as temperature fluctuated through all the temperature change, it remained the most stable, and it seemed to keep up with the conventional method tilled field, even though that's a common thing that people say that the no-till won't warm up very well.
Okay, so the next quality of good soil is aggregate stability, which is its ability to resist erosion when it's raining or due to wind. And soil aggregates are groups of particles in soil that stick together more strongly than other surrounding particles. And as you can see in this photo, this is during the winter, you can see that the soil has blown over on top of the snow, which is actually a technical term for that is snert. And that just shows that it is eroding a lot more than the no-till. So we've got a Slake test right here. We're gonna take a sample of no-till and a sample of conventional till and put it in water and see which one, how it erodes in the water. You can already see this is the conventional tillage, how it is breaking down in like sandy and it is getting cloudy already. And in the no-till, when it is eroding, but it is not eroding, it is eroding in bigger particles, which shows that it has much stronger aggregate stability.
All right, so bulk density is the weight of the soil particles divided by the volume that they occupy. And so the bulk density can change if the soil is more compact, then the bulk density is higher, and if it's less compact, then the bulk density is lower. So if you step on it or drive on it, then that'll increase the compaction and in turn the bulk density. And that's important because if you have a higher bulk density, you have a higher compaction, and so there's less space for water. And so it's harder for the plant roots to penetrate as well because they can't fit into those spaces as well. And so if it's driven on or stepped on again, that'll increase that, and that'll make the plant roots not able to go through, and it'll hold less water. So here we have a graph that shows the conventional till. You can see it has a higher bulk density and a lower percent water than the no-till, which is obviously lower bulk density, higher percent water. So we did our own test here, penetrometer. It's a rod that measures the amount of force that it takes to be inserted into the ground. And so we found that there was a much higher compaction, also bulk density, than in the tilled field versus the reduced till in the prairie. And here's the graph. It starts at 200, so it's slightly misleading, but you can see the tilled is much higher than the prairie and the reduced till. And so,
All right, now we're going to compare the yields now that we've looked at all 5 qualities of good soil. A common myth is that conventional tillage has much higher yields than what reduced tillage would have. And what is true, though, is when you first start conventional tillage, you will have higher yields, but as you continue to use that practice, you're going to erode all the topsoil, and you're going to have less productive seasons. And here's a comparison of the yields. This was done in Iowa. And we just took one of the regions. All the regions were basically the same. And as you can see, all the different practices of tilling pretty much have very similar yields. And then one thing to note is the operating cost for no-till is much lower. It's about half of conventional tillage, so your profit margin will be higher.
All right, so this is a cost comparison between, with 100 acres of corn between the no-till or reduced tillage and conventional methods. And as you can see, the conventional methods use a whole lot more fuel, almost double that of the no-till method. And at fuel cost at $3.23 per gallon for 100 acres, it is almost double, as you can see, and that's huge, huge savings that you can have with less tractor passes and a whole lot less fuel being burned, and in turn better for the environment.
To combat soil erosion caused by conventional tillage, the USDA recommends no-till and reduced tillage because less topsoil is exposed to the wind and less loose soil will be carried away with water. And as stated earlier, the Scientific American predicts that we have 60 years left of productive farming if we continue the current tillage systems.
all right, so now we have a video for you. This is going to show the runoff in conventional tillage versus reduced tillage. And as you can see on your left, my right, there's you're going to see a lot of water begin to flow into that the cup there, right here. And then on the other side, you're just going to see it all pass through. And that's because on my side, it's the conventional tillage, and so it's packed a lot more horizontally, so the water just runs off much more easily. Whereas with the reduced till, it's packed more randomly, and so it'll fall through. And you can see it starting to fill up the cup there with the runoff. And then another important thing to note is that in the reduced till, you don't see any water in the cup because there's not as much runoff. And then here's some more pictures of the snert. As you can see here in the conventional tillage, the soil just blows away a lot more easily, and then it gets into the snow, and it's really quite visible because the snow is white. You don't see it as much in the summer, but it's really visible in the winter. And then here we have reduced till, which is the snow is just perfectly clear. There's no snert in the reduced tillage.
All right, and then another environmental impact I did not know about was CO2 emissions. When soil is tilled, you actually emit CO2. And since world agriculture began, about 80 billion tons of CO2 have been let out into the atmosphere. And that's more than coal and oil burning combined up until the 1950s. And if you reduce tillage, you reduce the CO2 emissions. And if you do leave soil alone long enough, it actually does start to absorb CO2. So you would help reduce greenhouse gases.
Okay, the reason that a lot of people use conventional tillage is because it has been used for hundreds of years. And it takes care of weeds, which many farmers, that's a good reason why they use them. And no-till doesn't work for all soil types, clay or depends on the topography, if it's very hilly. And some people just aren't educated on other tillage methods that can work very well. And another reason some farmers do not switch over is because new tillage systems are very expensive, and a lot of them have invested a lot of money in the current ones. And but there are programs out there like EQIP, which is Environmental Quality Incentive Program, to offset some of the costs of the tillage systems.
All right, and we did a few interviews to figure out what farmers are thinking about reduced tillage versus conventional tillage. The first one we did was with Edwin Moss. He is currently switching to reduced tillage methods, and he lives in Winona, Minnesota.
He switched over because he grew up seeing the effects of tillage on the environment, mainly erosion, and his equipment was compatible, so he thought it wasn't that expensive, so he thought he'd give it a shot. And many farmers in the area were also trying it out, so he thought he'd do it as well.
We interviewed Ed Terry. He's our local FFA instructor, and when we asked him about reduced tillage, he thought of two E words, and he thought economics and environment. With the economic side, it saves on fuel and time, and with the environment, it reduces erosion and reduces sediment that is eroded into the streams and waterways.
We also interviewed Steve Neal. He's a leader in our 4-H club, and we asked him the question, why do you think some farmers are resisting change to reduced tillage? And he mentioned that there's been a lot of switching over recently. Many farmers have been changing from moldboard plow to chisel plow and other reduced tillage methods. And he also just said that farmers are pretty conservative and don't change because they don't feel like it. We also interviewed Charlie Radman. He currently practices only no-till, and he said that as a beginning farmer, there were 4 reasons that he just went with no-till right off the bat. One is he didn't have to pay for a larger tractor with the big tilling equipment. He didn't need multiple tractors. He could just stick with a single tractor. There was also less operating cost. He said he cut his fuel usage by 40%. There was less time involved in that, so that was less time he had to take away from his job and more time he had to spend with his family. And then also there was an increased organic matter and less environmental impacts he said he was noticing. Here we have some examples of no-till and reduced tillage equipment systems. They're
And then we toured one of them because it was in Faribault, Minnesota. It was close by, and we were able to get there. And it was called Environmental Tillage Systems. This is an example of one of the units they use. They have zone tillage is what they call it, and they tear up 1/3 of the land instead of the whole entire field, which is reduced tillage.
Getting back to the demo, a lot has happened. You can easily see how clouded up the conventional tillage sample, the water has been. And right here you can easily see how the soil particles have grouped together and allowing for the water to stay clear instead of getting cloudy like the conventional tillage, so showing that it resists erosion much better.
All right, the summary. Reduced tillage shows much higher quality in all 5 aspects of good soil. Reduced tillage greatly reduces your environmental effects, and it saves money while keeping your yields up high.
So in conclusion, the world population is increasing exponentially, and current farming methods are not sustainable. Current methods of tillage are reducing the 5 qualities of soil, reducing yields, costing the farmer more, and causing environmental impacts such as erosion and CO2 emissions. Farming needs to change so future generations are able to have sustainable and productive agriculture. We need to farm for the future.
We'd like to thank David Legvold for being our mentor because he has helped us incredibly with that.
And these are all the people we'd like to acknowledge who have helped us in some way get to where we are.
Here's our sources. We used a number of websites, lectures at colleges, tours, and journals.
Yeah, the presentations, we gave them, and then we had farm experts review our data and presentation. Thank you for listening. Any questions?
I actually have two questions. The first one is, when you did your soil sampling, how many different fields and parts of the county did you do your soil sampling?
Well, we did it in 2 fields that were really close to us. They were actually quite close together, less than 100 feet apart. So the soil type was very similar, but we didn't investigate all over. It was mostly just in 2 fields.
And that's a place we could expand on, is comparing multiple different soil types, not just the one we studied there.
Then my second one has to do with your CO2 emissions. Generally, research that I've seen has supported that CO2 emissions, or that they increase with decomposing plant matter, especially wetlands and that. So I'm just curious what were your sources were that supported the CO2 actually lowering with your keeping crop residue in your fields.
I'm not quite sure what, I know it's a credible source, I'm not quite sure I remember the name of the source, but I believe the reason for it would be that a lot of organic matter is underground too, and that would keep it in the ground versus like conventional tillage turns all the soil up, and you'd expose some of that organic matter to the air, and that would allow for the CO2 to be emitted.
Can you share a little bit more about your relationship with your mentor and your coaches, and how you came up with this topic and what their involvement was?
Yes, David Legvold is one of our neighbors, and he has been heavily involved in a lot of things with 4-H, and he works at the St. Olaf College, and he was also head of the Cannon Watershed. And we found him because we listened to him speak one time at St. Olaf about reduced tillage. And so my mom and I, well, my mom's the coach and Hoken's dad is the coach. So we asked him, and he was very happy to work with us. And we were very intrigued by different tillage methods. And David Legvold was like really, really outgoing to help us with our investigation. And he led us in the right direction for creating our own tests and what tests we can do to really show the comparison between the 2 tillage methods.
Adam Burr with Minnesota Corn Growers. So you alluded to some of the challenges associated with no-till. In your studies or review of the literature, are there parts of Minnesota where you think this is more appropriate practice than others, or is this something that can be used across all of Minnesota? What have you seen through that?
Well, obviously we alluded to this with the clayey soil. It doesn't really work as well. In our area, it's more loamy. It works just fine. In Winona, obviously, it's more hilly, and so it's very useful, because then you don't have as much you don't have as much runoff, and so then you don't lose as much dirt, which is obviously a danger in the hilly areas. But yeah, it doesn't work everywhere, but it does work in our area. So.
Sometimes with conservative conservation farming methods, there are challenges with disease and insects. And is your research, are you planning on expanding into any of that? Kind of keeping that residue on the field sometimes presents other challenges in other areas. And I'm just wondering if you're planning on expanding into that research as well.
We definitely thought about going into testing or looking into the different herbicides and pesticides that we need to use, that are needed to be used in the different methods. But that would have to be for future. We didn't have enough time to look into that, and it would definitely take a next season so we can really follow what they're using. The farmers that we talk to, at least, we can follow what they're using, and if they're having issues with certain species of insects or different strains of disease.
You did an interview with some folks about no-till. Do you see maybe some advantage to doing a survey of folks in your county to see some of the factors that go into their tillage decisions?
I think a survey would be very valuable because we only had about 4 or 5 interviews, I believe. That's only 4 or 5 opinions. A survey would, be able to cover hundreds of farmers in the area, which would give a more broad viewpoint of reduced tillage and what others think.
And that table we had was what we found, or what was available to us as a survey. When we asked at the extension office, there's the Dakota County Water and Soil.